to the mathematics lesson under the topic matrices. Under the topic matrices. Okay? And our subtopic for today will be solving linear equations in two variables. My names are Skombe Mutambo Fanny, and I'll take you through this lesson. Now, when we were in grade 8 and 9, we looked at simultaneous equations. What are some of the methods that we used when we were solving simultaneous equations in grade 8 and 9? Ruth at the far back?
Elimination method.
Elimination method, very good. Anaconda?
Graphic method.
Graphical method, very good. And Mary?
Substitution method.
Substitution method. Now, those are the methods that we used when we were in grade 9. Now, since we have moved a step forward, we are going to look at the two methods that we're going to be using. And these are the matrix method and the Crammers rule. So today I'm going to take you through the Crammers rule on how we can solve linear equations in two variables. So we are going to look at the Crammers rule, right? Right. Now, when we have been given two simultaneous equations, we have been given simultaneous equations and we want to solve them using Crammers rule. There are three matrices that we extract. Three matrices that we're supposed to extract. Now, an example that I will give is, let's look at this chart. We have two simultaneous equations which are in two variables, isn't it?
Yes.
Okay, so I said we are going to extract three matrices from the two linear equations, okay? Now, we have the first one here, which is the coefficient matrix. That is the first matrix, coefficient matrix. How do we come up with the coefficient matrix? Number one, look at the coefficient. Why is it called the coefficient matrix? We have 2x. 2 is a coefficient, isn't it?
Yes.
And x is a variable. Here we have a coefficient of 1. Here we have a coefficient of 1. And here we have a coefficient of 3. This is the more reason why this one is called the coefficient matrix. We just pick the coefficients. And here we have the coefficient of 2. This is the 2 that we have put there. Here we have a coefficient of 1. This is the coefficient that we have put here. Here the coefficient of y, we have 1. Here the coefficient of 3y, it is 3. So after you extract these, we now move to the next one, which is the matrix of variables. That is the second matrix that we are going to extract from there. Now, the matrix variables, you know that the letters there, they are called variables, isn't it? Yes. And we have the letters x and y. And this is the more reason why we have x and y. And we represent this in a matrix form. As you can see the brackets that I've put there. Right?
Yes.
We move to the next one, which is the matrix of constants. The matrix of constants, you know that a constant is a number that stands on its own without a variable, isn't it? Yes. So we are going to look at 7 and 11. We don't have any variable there. So these are called what? Constants. So we are going to pick them the way they are, which is 7 and 11. So we have extracted how many matrices? 3. So these are very important because they are going to help us in solving the equations that we are going to be that are going to be given as examples using the Crammers rule. Hope we are clear on the matrices that we're supposed to extract before we begin solving. Yes. Are we clear?
Yes.
Any questions? No questions. Very good. So we'll move on. I'll pick the same equations and put them there as example number 1. Okay? I want you to pay attention. Example. These are examples. So we have example number 1, right? So solve the following systems of linear equations. So solve the following systems of linear equations. So the first one, I'll pick the very one that is on the chart, which is 2x plus y is equal to 7. Then we have x plus 3y, which is equal to 11. So we have 2 equations there. Okay? Yes. All right. So 2x plus y is equal to 7. Then we have x plus 3y is equal to 11. These are the 2 that we have been given. So we're going to extract the equations that I talked about. So I said the first one is the coefficient matrix. So I'll pick, here we have the coefficient of 2, here we have the coefficient of 1. I'll write them in matrix form. So I have 2 here, I have 1. This is the x column, isn't it? Yes. Then I'll pick the 1 there and the 3 there. So I have 1 and the 3. This is the column for the y. Okay? So write it in matrix form. Then we are going to pick the variables, which is the matrix of variables. We have x and y. So we're going to have x and y in brackets. Then we equate this to the last matrix, which is the matrix of constants, which is 7 and 11. All of them are supposed to be written in matrix form. Alright? Then we move on. Remember in the previous lesson we looked at how we can find the determinant, isn't it? Yes. We know how to find the determinant, but I'll take you through. So here we are first going to find the determinant. So D is my determinant. This is equal to, you know that this is the major diagonal, this is the minor diagonal. How do we find the matrix when we are given, how do we find the determinant when we are given that matrix? How do we find the determinant, class? Yes, Marjorie? There?
Major diagonal minus the minor diagonal.
Major diagonal minus the minor diagonal. How do we find that? Yes, Chirufia?
First we multiply the major diagonal, which is 2 times 3, and then we also multiply the minor diagonal, which is 1 times 1. Then our answers, we're going to subtract them.
Very good. So it's the product of the 2, isn't it? Yes. The product of the major diagonal subtract the product of the minor diagonal. So here this is the major diagonal. So this will be 2 multiplied by 3. Then we subtract the product of the minor diagonal, which is 1 multiplied by 1. Are we all there?
Yes.
So our determinant is equal to 2 multiplied by 3, 6. Then minus 1 multiplied by 1, 1. So when we subtract there, it's going to give us what? 5. So this is the main determinant, right?
Yes.
Then from there, we are going to find the x determinant, right? What do I mean by the x determinant? This is the x column, isn't it? So when we are finding the determinant of x, we are going to replace this x column with our matrix for the constants, right?
Yes.
So what we are going to do is we'll get our matrix the way it is, but we'll only change on the x. This is why it's called the x determinant. So it's going to be x determinant of x will be equal to, remember I said because we are dealing with the x column, yes, right? We substitute the variables of the constants, okay? So here we're going to replace that by that. So this will be 7, 11, then we pick the y the way it is, right? Yes. So this will be 1, 3. So we find the determinant. We already know that it is the sum of the major diagonal subtract the sum of the minor diagonal. Clear?
Yes.
Right. So we'll move and we'll say determinant x is equal to 7 in brackets multiplied by 3 minus 7 multiplied by 1 multiplied by 11, like that. Clear?
Yes.
So our determinant x will be equal to what is 7 multiplied by 3?
21.
Good. Minus 1 multiplied by 11?
11.
So determinant x will be equal to 21 minus 11, which will give us what? 10. So this is the x determinant. Right. From there, for us to find the value of 1, of x, we know that from our matrix, we're supposed to find the value of x and the value of y. So in order for us to find the value of x, we are going to say, therefore, x will be equal to this determinant of x. So the determinant of x will divide by the main determinant here, which is what? 5. So we'll put the main determinant like that. Then we'll say x, then we substitute. dx is equal to 10. So this will be our 10. Divide. What is our main determinant here? 5. So we'll put 5 and divide. So what will be our x there? 2. Very good. So this is the value of x. Now we need to find the value of y. Understood?
Yes.
Okay. So we'll still go back to our main matrix here. Right?
Yes.
Okay. So it will be dy is equal to, open brackets. Now because we are finding the y, where we have the y column, we substitute the what?
The constants.
The constants. Do we understand? But we maintain the values for x. We don't change. Right?
Yes.
So the matrix that we are going to have here will be 2, 1. Then we change for y by substituting with 7 and 11, like that. Then we find determinant of y. Again, we go back to our determinant, which is the major diagonal, the sum of the major diagonal. You subtract the sum of the minor diagonal. So this will be 2 multiplied by 11. So 2 multiplied by 11, then minus 1 multiplied by 7. So our dy will be equal to, what is 2 multiplied by 11? 22. Then minus 1 multiplied by 7? 7. So what will be our dy? 15. Very good. So we go back, we are finding y. Okay? So our y, therefore, will be equal to the dy divided by the y. Clear? Okay, so we move on. Y will be equal to, what is our dy? 15. So we have 15. Divide. What is our main name? Sorry, here it's supposed to be main determinant. What is our main determinant? 5. So let's divide there. What is our y? 3. Y is equal to 3. So now you make your conclusion and you say, therefore, your x is equal to 2 and your y is equal to 3. This is our answer. Now, if you want to prove that your answers are correct, you simply get the value of x and the value of y and substitute in the main equation. Okay? So what is our x there? It is 2, isn't it?
Yes.
So what is 2 multiplied by 2? 4. Isn't it?
Yes.
And what is our y?
3.
So this is 4 plus 3. What's your answer?
7.
This is our 7. Then it means our 2 is correct. Are we clear? Then let's substitute the other one. X here is what? 2. And then plus 2 multiplied by the y there. 3 times 3 is what?
9.
So 9 plus the 2?
11.
Is the 11. Then it means our values for x and y are Correct. It's very straightforward, isn't it?
Yes.
All right. Any questions before I move to the next example?
No questions.
No questions, you are clear?
Yes.
Good girls. Right. So I'll present the next question, which is B. So this is 3x minus 2y is equal to 12. Then x plus 3y is equal to negative 7. Right?
Yes.
So in the same way that we worked out the first one, that is the way we are going to deal with that. Who can tell me the first step? Yes, Rachel at the back.
We're supposed to come up with 3 matrices.
Can you mention the first one and the second one and the third one?
The first one, we're supposed to find the coefficient matrix. Then secondly, we're supposed to find the matrix of variables.
Yes.
And then lastly, the matrix of constants.
Those matrices we're supposed to find here. So can someone now give me the first matrix, the second one, and the third one? She has explained. Someone to come up with those matrices? Mariam, the first one? Mariam?
Firstly, we're going to put 3, open brackets, 3, 1, then 2, negative 2.
Negative 2. Let's give space here. Negative 2, yes.
3.
3. That's the first one.
Yes.
Finish it off. The next one.
Open brackets, x, y.
Y. Okay. We equate these two.
Yes, and then for the constant, 12
Yes.
and negative 7.
And negative 7. Very good. Give her a clap. Okay, so these are the 3 matrices that we have. So we have found the matrices there. What is the next step? What is the next step? Yes, Charity at the back.
We're supposed to find the main determinant.
We're supposed to find
The main determinant.
the main determinant, isn't it?
Yes.
Can you explain to us how we can find the main determinant?
You multiply the major diagonal by the minor diagonal.
Very good. Do we all understand?
Yes.
So this is the major and this is the minor. So the main determinant is equal to 3 multiplied by 3. We subtract negative 2 multiplied by 1. Right. Next step. Next step. Yes, Kuzwa at the back.
We're supposed to find dx. And then to find dx, we will
Yes, go on, go on, go on.
after you have subtracted there, find the main determinant.
We find the main determinant.
Yes,
Okay,
after subtract.
very good. So D, which is the main determinant, is equal to what is 3 multiplied by 3?
9.
Then minus. We open there. Why are we opening? We have the negative there.
Yes.
Negative multiplied by the positive 1.
Negative 2.
Negative 2. Right? Very good. So our determinant will be equal to 9. Negative multiplied by negative? It will be a positive 2. So D, which is our main determinant, will be equal to 9 plus 2?
11.
So this is our main determinant. Now, we start finding the other determinant by replacing the x column with the constant. Then we find for x and we continue like that, isn't it?
Yes.
So here we are going to find the dx. So the dx will be equal to, we'll substitute the x column with the constant there. So it will be 12, negative 7, then we have negative 2 and 3. Right?
Yes.
So what is our dx? This will be equal to 12 multiplied by 3. 12 multiplied by 3. Brackets like that. Then we have negative 2 multiplied by negative 7. Are we all there?
Yes.
Okay. So we use that part. So what is 12 multiplied by 3?
36.
So we're still finding the dx, which is equal to 36. Then we have a minus there. Sorry, 36. Minus negative 2 multiplied by negative 7.
14.
So this will be positive 14. So that positive multiplied by the negative there.
Negative.
So it will be negative what?
14.
Right? So our dx will be equal to 36 minus 14. 22. So this is our what? Dx. Now we find the value of x. X will be equal to dx divide the main determinant. So x will be equal to, what is our dx? 22. And what is our d?
11.
So when we divide there, what will be our x? 2. So this is our x. Now we need to find y. So our dy will be equal to, we'll replace using the main matrix, right? Which is this one here. So we'll replace the x, the y column with our constant. Okay? So just give me the values that are there. The first one for the matrix 3, 1. Then for the constant 12. Yes.
Negative 7.
Negative 7. Right?
Yes.
So our dy will be equal to 7 multiplied by, 3 multiplied by negative 7, then minus 1 multiplied by 12. So our dy will be equal to, what is 7 multiplied by, 3 multiplied by negative 7?
Negative 21.
Negative 21, then minus, what is 1 multiplied by 12?
12.
Yes, we have negative and negative there. We know what we're supposed to do, isn't it?
Yes.
The negatives, the signs are the same. Therefore, we're going to add and maintain the sign. So dy is equal to, when we add the 2, it will give us what?
Negative
33. So this is our dy. So we need to find y. So our y will be equal to dy divided by the main determinant. Clear?
Yes.
So our y will be equal to, what is our main determinant? What is our dy?
Negative 33.
Very good. Divided by the main determinant that we found there, which is
11.
So our y will be equal to, we have the positive number there, we are dividing with the negative value there, isn't it?
Yes.
So when we have positive and negative and we are dividing, what will be the sign?
Negative.
Negative. Then divide 11 into negative 33.
3.
Negative 3. So this is our y. We conclude, therefore, x is equal to 2 and our y is equal to
Negative 3.
or negative 3. Then you can substitute this in the main equations that we have given to prove that the answers here are correct. Okay? So this is how we can find the values of the variables using Crammers rule. Any questions? Yes, at the back.
Is it possible to have a column where the variables are different?
Different as in?
Where instead of there being x at the top and x at the bottom, there's x at the top and y at the bottom.
X at a,
At the top.
give me an example.
2x,
2x.
and then this side is going to be y or x squared.
Plus. Give me a value here.
X, that's x.
X.
And then at the bottom, there's going to be y.
Here y. Then maybe we have minus 20 or 20y like this.
Yes.
Then we equate this to 2, then equate this to 1. This is not possible in the equations in 2 variables. They are saying equations in 2 variables. So the variables are supposed to be how many? 2, which are different. When you give me x and x here, it means you have one variable. You understand?
Yes.
This is x and this is x, so you have one variable. This is y and this is y, you have one variable. So in one equation, you're supposed to have two variables which are different. This is the more reason why it is called linear equations in two variables. Two, meaning that variables are supposed to be different in one equation. And it's not always that we're going to be using x and y. Sometimes these variables, they can use different letters, okay?
Yes.
For instance, you can have 2n plus 4m is equal to 10. Then here you have 4n minus 20m is equal to 19. So it's not always that they're going to give you x and y. Hope I've answered your question.
Yes.
Okay, very good. So I want you to go through, or at your own time, you practice the questions that I'm going to give you. Okay?
Yes.
Right. So you can jot down these and practice them. Okay? It's very important. So we have the task there, which we are going to do or practice at our own time. Right?
Yes.
So we have the question solve the following. So the following pairs of simultaneous equations using the Crammers rule. Right?
Yes.
Or the Crammers method. Okay, so we have the first one, which is 2x plus 3y is equal to 5. Then we have x plus 2y is equal to 3. Then the second one, which is b, is 4x minus 5y is equal to negative 3. Then we have 3x plus 2y is equal to negative 8. Right? Then we have the third one, which is 3x plus, this will be x minus y is equal to 8. Then 4x plus y is equal to 42. So in your free time, you can go through these questions and answer them. Okay, learners, this is the end of our lesson for today. I encourage you to continue practicing for you to pass mathematics, okay? From me, as Kombe Mtambo Fani and the entire crew, we say bye-bye.